Chapter 10, Lesson 3, Triangles. Okay, the first thing we're going to do is look at some definitions. I know you know what a triangle is, but just to kind of be very technical about things, a triangle is made up of line segments. So the definition of a line segment is it's a part of a line containing two endpoints and all the points in between. So a line, remember, goes on and on forever, and it's a bunch of points. A line segment is a point and another point. Those are the endpoints. And it contains all these points in between. So this portion of the line would be a line segment. And a triangle is made up of three line segments, and they're all joined at the end points. So they're only joined at the end points, and the vertex is the point where those segments intersect at their end points. So let's put that into a picture. So here's a triangle, obviously, all right? And it's made up of three line segments, and they all have these end points on them. So this is a line segment. And then all three of these are called a vertex. The plural of that, if you might see it, is vertices. And it's just the plural vertex, okay? Then a triangle also has three different angle measures, right? We have an angle that's here, we have an angle that's here, and an angle that's here that's made from the line segments. And the sum of all three of those, when I add them together, is 180 degrees. Which allows me, if I have a triangle and I have one missing angle and I know the other two, I can find it. Because this angle measures 54, this angle measures 89, and I need to know what this angle is. So 54 plus 89 plus x equals 180. And so I can add the 54 and the 89 together and get 143 plus x equals 180. Subtract the 143 from both sides, and x equals 37 degrees. It's important that we set up that formula because when we get into more algebraic problems, then that formula will be important. Okay, so if I have an acute angle, so now when we talk about triangles, we also talk about their angles. An acute angle is less than 90 degrees. Right, and an example of an acute angle might be this, because this angle might measure 42 degrees. A right angle is a 90-degree angle, remember, like a corner. So this could be a 90-degree angle, a right angle. An obtuse angle is an angle between 90 degrees and 180 degrees. So it might be something like this, and maybe this angle measures 121 degrees. And a straight angle is a 180-degree angle. And so it's going to look like this, and usually we see a vertex, one end point of the two rays that is joined together, and then we say that this whole thing is 180 degrees. Now, if I'm going to classify angles, just very simply, I look at them and I say, okay, well, there's my angle. This would be like a right angle, so since it's less than that, it's acute. And then I would say, okay, well, this one, since it looks like a right angle, 90 degrees, I would say it's right. And this one, if I made a right angle, it's bigger than that, so it's obtuse. If you have a paper, you can actually use a corner of your piece of paper to fit inside of there and to decide what kind of angle it is. Okay, so now let's look at how we classify our triangles. So if I'm going to classify my triangle, and I'm going to decide if it's an acute, an obtuse, or a right triangle, is what I'm going to do is I'm going to look at the angles. Okay? And that's all I'm going to care about when I'm classifying it by the angles. If it's an acute triangle, then all three angles are acute. All three of them must be acute. If it's obtuse, one angle, not all three, is obtuse. The other two are going to be acute. And in a right triangle, again, one angle is right, is 90 degrees. Okay? And then if I'm going to look at its sides, we have two ways to classify it. One way is I say that it's acute, obtuse, or right. The other way is that I say it's equilateral, isosceles, and scalene. So it can be two. We choose one from each category, one from the angles category and one from the sides category. An equilateral triangle has all three sides equal and an equal measurement. So now we're not talking about angle degrees, we're talking about the measurement of this side in inches or feet or meters or millimeters. If it's isosceles, it has two sides the same or equal measurement. And if it's scalene, it has no sides equal. Okay, we'll also see that word congruent used. The sides are congruent or not. So equilateral has all three congruent sides. Isosceles has two sides that are congruent and one that's not. And scalene has no sides that are congruent. Okay, now something that's just a little hint to help you. That if a triangle has three congruent angles, so if the angles are all the same, even if you don't have something to measure the sides, if the three angles are all congruent, it will have three congruent sides. And that works for other numbers. If the triangle has two congruent angles, it will have two congruent sides, which makes it isosceles. And if a triangle has zero congruent angles, it will have zero congruent sides, which would make it scalene. So we can tell actually if it's scalene, isosceles, or equilateral based on the angles, because it helps me to know if the sides are equal or not. Okay, so I know these examples aren't on your paper. You can draw them if you want. But if I was going to classify these triangles based on their angles and sides, so let's look at this one over here first. And so I'd say, okay, the angles are 40, 88, and 52. They're all less than 90, so it's acute. And since all three of them are different, then the three sides are different, and it's scalene. I don't even have to know how long the sides are. All right, let's look at this one. So I have 45, 45, and a 90. So this 90-degree angle tells me that it's a right triangle. And then since I have two angles that are the same, it is isosceles. And then my last triangle, I say, okay, 60, 60, 60. So they're all acute. So it's an acute triangle, and they're all equal, so the three sides are equal. So it's also equilateral.